Good morning, students. So today we are going to continue with our chapter. Now, in the previous video, we have seen how to convert these kind of numbers, that is, non-terminating, non-recurring decimal expansions into the P by Q form, right? So let us revise once, taking one example. Now here I have taken the number 1.27 bar. 27 bar means 27 is repeating. So this number is 1.272727, etc. Right? Now here I have taken x is equal to 1.27 bar. Why is that? Because that is how we are supposed to do, right? Whatever number is given, we need to take it as x first, right? Now we see after the decimal point how many numbers, how many terms are repeating. Two terms are repeating, 27, 27, 27, etc. 2 and 7 is repeating always, so two terms are repeating, right? So since two numbers are repeating, two digits are repeating, we use 100 on both sides to multiply, right? If 3 were repeating, 1000. If 1 was repeating, 10. Likewise, if 2 are repeating, 100 should be multiplied on both sides, right? So we multiply both sides by 100. X is multiplied by 100 becomes 100x. 1.272727 is multiplied by 100 in this step, right? Now 100x will remain 100x till the last second step. Until then we will be solving the right hand side. In the right hand side, as we know already from the basics that we learned in the previous video, since it is multiplied by 100 and there are two zeros, so this decimal point will move two places to the right, right? So the decimal point moved two places to the right and it became 127.2727, etc. right? So in the next step we get this. Now what is my next step? My next step is whatever number I got here, I have to split this number into two parts, right? So to split this number into two parts, and I know that one part should definitely be x. Why? Because x is the number that we have given, right? So one part should definitely be x. Yes or no? So that is why in order to split, we have seen how to do it. First, we take this number that we got in this second step. First, we take this number that we got. So here, let me show you this number we have taken here, right? Now you can see that I did not take all the digits. I took only two digits after the decimal point, two places only, right? So the first number that we take is this number that we got in the second step. Now the second number that we take is this number, right? X, we take x, whatever number we have been given in the question, that is our second one, right? So x is our second one. Now here also it's 1.27272727, etc. But I've taken only 27. Why? Because here if I take two numbers, I have to take two numbers here also, right? So that is why. Now let me minus them, let me subtract them. So when I subtracted them, obviously everyone knows how to subtract, right? So you should know how to subtract, okay? So after subtracting we get 126, right? Now 7 minus 7 was 0, 2 minus 2 is 0, 7 minus 1 is 6, 2 is as it is, 1 is as it is. So we get 126, right? So after we subtract, whatever number we get, we have to write it here, right? So we write it there, and whatever number is given in the question, x, we write it here, right? Why do we write this? Because look, why did we split it into two parts? Splitting means what? Whatever number I got here, 126, right? This number plus this number, just plus it and see, 1.27. So whatever we got here plus whatever is this number, if you plus it, you're going to get this number, okay? You're going to get this number, okay? The answer is going to be this one. Let's see whether the answer is that or not. 7 plus 0 is 7. 0 plus 2 is 2, right? 1 plus 6 is 7. And point is again here, decimal point, don't forget, because here also decimal point and here also decimal point, right? Now 2 will repeat as it is, and 1, right? So we get 127.27. 127.27 is this number itself, right? This number itself. So that means I know that, because why? Because 5 minus, look, let me give you an example. 5 sorry, 5 minus 3 is what? 2. You know that, right? 5 minus 3 is 2. Now you can see that if 3 goes to this side, it becomes plus 3, right? So 3 goes to the other side, becomes plus 3, right? So 2 plus 3 is what? 5 itself, right? So that means when I adjust these numbers, I will get this number itself, right? So likewise, we used it here. So this is just common sense, right? So using your common sense, you can arrive at this, right? So after that, what did we arrive at? We arrived at that 127.272727, etc. is when split into two parts, it becomes 126 and 1.2727. Okay, now if this part is not clear to you, this is just a revision question. This question is done in detail, step by step, in the previous video, so please go and watch that video. Okay, if you are not clear with this, please make sure that the previous video is properly done, and only then you are starting with this one, right? Okay, so now let's continue. Okay, so 127.2727, etc. I've split it into two parts, and the first part is 126, which I got from here, and the second part is x, which I already have from my question, right? Now in the next step, our only job is to write x in place of this number, because this is x, right? So we wrote x in place of that number. Now we have to bring all the x together. So 100x was already on this side, and x was on this side, so we bring x from this side to this side. When we take x from this side, one side of the equal to the other side of the equal to, plus becomes minus, right? So 100 minus x becomes 99x, and 126 remains 126 itself. Now x, I need only x, so I keep x at this side. 126 was already there, and 99, it's in multiplication with x here, right? Multiplication. But when it comes to the other side of equal to, it becomes division. So it becomes 126 divided by 99. So that is our answer. So that means 1.27 bar is actually 126 by 99, right? So this one we have seen clearly in the previous video. So now let's go on to the next part. Next part, based on all that we have studied up until now, we are going to be doing exercise 1.3. Okay, so the first question, let's look at first question of exercise 1.3. Now let's read the question. Write the following decimal form and say what kind of decimal expansion each has. So whatever number is given to us in the question, we have to write it in the decimal form. Okay, how do we find the decimal form? By dividing, definitely, right? And division is, everyone should know. You are in class 9, you should know how to divide, right? So I'll not be showing you how to divide. Everyone should know that. Now okay, write the following decimal form. So we have to write the given number in decimal form, and looking at the decimal form, we have to say what kind of decimal expansion is this. We have learned about three kinds of decimal expansion. First is terminating, then we have learned about non-terminating repeating, then we have learned about non-terminating non-repeating, right? So that's why first one we have solved it here. When I divide 36 by 100, I get 0.36, right? Basic division, everyone should know. So when I divide it, I get 0.36, and as I can see, none of the digits here repeats, right? So that's why this is a terminating decimal expansion. No other digits repeat here. After 36, the number ends, right? So it terminates. So we call this terminating decimal expansion. So very easy. Let's go on to the next one. 1 by 100, 1 by 11, sorry, 1 by 11, we solve it, we divide it using normal division. Once we divide it, we get this, which is 0.09090909, etc. So which means we can clearly see that 0 and 9 are repeating in a sequence, right? So what do we call this kind of expansion? We call it non-terminating, because it will infinitely expand, right? It will never terminate. So this is non-terminating, a repeating decimal expansion, because 0 and 9 are repeating in a sequence, right? The next question. Next is 4 1 by 8. As you can see, this type of fraction is called mixed fraction, which you have learned about in class 7. So if you do not know, please watch some video or ask someone and try to understand how mixed fraction is converted into improper fraction, right? This basic conversion you should all know. This is done in your lower classes. Okay, so now how do we convert it? First we multiply these two numbers and then we add it with this one, right? So 4 into 8 plus 1. So 4 into 8 plus 1 is 32 plus 1, which is 33, right? Now 33 by 8 is 4.125 when you divide it. Okay, so basic division I'll not show you. Okay, so they have told us, look at the decimal expansion 4.125. So it terminates and none of the numbers are repeating. This is what type of decimal expansion? Terminating decimal expansion. So this was a really easy question, right? So based on the knowledge of these questions, it's very easy. So please try to do 3 we have already done. So please try to do 4, 5 and 6 as homework. Okay. So 4, 5 and 6 are homework questions. Now, so the third question, let's read the third question. Express the following in the form P by Q, where P and Q are integers and Q is not equal to 0. So we have done these kind of questions, several questions now. So we are going to be doing this question again, and it's going to be a revision of what we have done in the previous video and in the beginning part of this video, right? So I'll revise, okay, because this is all based on steps. This kind of questions are very easy to score marks, and these are all based on steps because every question we follow the same step, this type of question, right? So let's see the steps. First step is what? To take the given number as x. So we take the given number as x, right? Now we look at the number, we look at how many digits are repeating. So here one digit is repeating, and which digit is that? 6 is the digit that is repeating, right? So here the digit 6 repeats, so therefore one digit is repeating. Therefore we take 10 to multiply on both sides because one digit is repeating. 2 digits repeats, we'll take 100. 3 digit repeats, we'll take 1000. So likewise we take one digit is repeating, so we take 10 on both sides to multiply, right? I multiply 10 here and I multiply 10 here and I get this step, right? Now 10x will remain the same till the last second step, and to this side we will solve 10 into 0.666 etc. Now it's 10 into, so the point or the decimal point moves one place to the right, so it becomes 6.666 etc. Now 6.666 etc. is going to be split into two parts. In order to split, what do? We first take this number, and since this number is repeating and it's never going to end, we can take as many numbers as we want after the decimal point. If I take one number after the decimal point here, then when I take the next number, I have to take one number itself. If I take 2, I have to take 2 itself. If I take 3, I have to take 3 itself. So here you can see I have taken only one, which is 6.6 only this part, the first part 6.6. So this number is the first number that I take. Then the second number that I take is the number that is given to us, right? What number is that? The number 0.66 is given to us. So that is what we take. Now 0.666, as you can see, 6 continues again, but I took only one place here, one decimal place here. So in the first number also I took one decimal place. Second number also I took one decimal place, right? Now I subtract them and I get 6, right? So when I subtract, I get 6. That means I can split this number into two parts. The first part is 6, which I got from here, and the second part is x. Every question, the second part should be x, right? That is the reason why we do this step, so that we can get one number such that we will add it with x, then we get the previous step, okay? So anyway, this step, then we split it into two. Splitting process is explained here and in the previous video also. So make sure you know that. I'm not going to deeply teach that right now because in the previous video we have seen it deeply, okay? Now instead of 0.666 etc., I can substitute x because it is x as given in the question, right? So 6 plus x in place of this. Now x wants to go to the other side because all the x should come together, right? So x, when it goes to the other side of the equal to, it becomes minus because here it was plus. So 10x minus x, 10 minus 1 is 9, x, so answer will also have x. Then 6 was already there, so 6 we wrote it down. Then x is equal to 6 by 9, right? Here x is equal to 6 by 9. Why? Because 6 was already there, 9 is in multiplication. When it goes to other side of the equal to, it becomes division. So 6 by 9, right? So therefore, I can say that what is x? X is 6 by 9. And what is x? X is 0.6 bar. So 0.6 bar is 6 by 9, right? So let's see the second one. Now the second one is 0.47 bar, right? Now whenever you look at the question, before solving it, always look at how many numbers have bar on top. So be careful of that. Sometimes you might feel that there is a bar on top of 4 also, but look at it carefully here. There is no bar on 4, okay? So the only repeating number is 7, right? So make sure of that, okay? So what is the first step? Take the given number as x. So we did that. Now look at the number. How many digits are repeating? Only one digit is repeating. Which digit is repeating? 7 is repeating. The second digit, 7 is repeating, right? So only one digit is repeating here. So this is basically 0.477777, etc. Right? So 7 is repeating. So one digit is repeating. So therefore we multiply both sides by 10, right? So 10x, 10 into 0.4777, etc. the number. Then since we multiplied it by 10, I know that it will move one decimal point, the decimal point will move one place to the right, right? So it moves one place to the right and it becomes 4.777, etc. Now 10x is 4.777, etc. Now this number, I need to split it into two parts. The first part should be, how to obtain the first part? I take this given number here up to some certain decimal point. Here I took only one decimal point, which is 4.7. I took only 4.7. I can take 4.77 also. I can take 4.777 also. No problem. How many 7s you want, you can take that much. Only thing is, when you take the second number, then that much itself numbers should be there on this side. If there are 4 numbers on the side, 4 numbers on the side. 3 numbers, 3 numbers. If there are no numbers, no numbers, right? But always remember to take one decimal place, okay? So at least one should be there. It's not like you don't know how to solve decimal, so don't take one. No, you should not do that. You should take one number after the decimal point always, okay? So this is 4.3. So we have got 4.3 here. So that means I can split this number into two parts. The first part is 4.3 and the second part is always going to be x, the number that we have been given in the question, right? Why? Because when you add these two numbers, you will get this number 4.777, right? Why? Because when you subtracted it, you got 4.3. So when you add it, you'll get 4.7, right? So anyway, so this one we have seen split it into two parts. Then what we do, we write 10x as it is, 4.3 as it is, and in place of this number we can write x because this is x, right? Now x wants to come to this side because we have to bring all the x together. So 10x minus x becomes 9x, 4.3 becomes 4.3. Now before taking the 9 to the other side, first we need to remember that we need to remove the decimal point because we have to express it in terms of p by q, right? We have to write p by q. So that means we have to not write p point something by q. No, p should be an integer. It should not be a condition is what? We have to express it in p by q form where p and q are both integers, right? So therefore 4.3 has to be converted into an integer. 4.3 is not an integer, right? So 4.3 has to be converted into an integer. For that, I've shown you the method how to write 4.3. Since there's one decimal place, since there's one number after the decimal point, we take 10 below, right? So 43 by 10. So 44.3 can be written as 43 by 10. Now this 9 goes to the other side, becomes division and multiplies and becomes 90, right? So x is 43 by 90, okay? So x is what? X is 0.47 bar. So we can say therefore 0.47 bar is 43 by 90. So can you see the given question we expressed it as p by q form, okay? So I've gone a little bit fast in this portion because we need to finish our portions. We are a little bit lagging behind, and also because I have already done this in the previous video in a very clear manner. Okay, so please watch that and learn. I'm telling you this again and again to emphasize on it. Okay, it's important. Please do it. Now let's go on to the next one. Next one is 3. 3 is very easy, just like these two questions itself, and since we have done around 5 questions by now, you must follow the same steps and you must do it by yourself as a homework. Okay, so let's look at the next part. Now again the same type of question, only difference is they have not given us bar, instead they have given us the same number. So please look here, I'm going to go really fast here because it's the same question. Express 0.999 etc. in the form P by Q. So 0.999 is what? 0.9 bar, because 9 is repeating, so 9 will have a bar, right? So x is equal to 0.9 bar. So since there's one digit repeating, we take 10 and multiply on both sides. Then here, since we multiply by 10, point moves 1 point to the right, so it becomes 9.999. Now I need to split this into two parts. So first part, how do I find? By taking this number and by taking this number, and both should have equal numbers after the decimal point, right? So 9, one digit here, so one digit here. So I take 9.9 and 0.9 and I subtract them and I get 9, right? So this is the first part, and the second part will every time be x, right? Whatever number is given, it will be x. So that itself. So now in the next step, 9 will remain 9, 10x will remain 10x, 0.999 will become x because it is x, right? So now 10x minus x will become 9x and 9 will remain 9. X will become 9 by 9 equal to 1. So therefore we can see that 0.9 bar is 1. Now they have told us in the question that to look at the answer, and they are asking us to think about the answer and also to discuss with our friends and teachers. So what is there to discuss about this? Look here. Now this is a number which is 0.999 etc. Now can you see that this is a decimal point number? This is a decimal expansion. Now how can one number be equal to another number, right? Because every number is unique in mathematics, right? So how can one number be equal to another number? Look here. 0.9999 etc. by the process of approximation. Okay, so you already know, right? Suppose you have 9 rupees and 50 paise. Suppose you spend 9 rupees and 50 paise in a shop. What do you tell to the shopkeeper? You either tell them to take 9 rupees only, or you tell them to take 10 rupees only. What did you do? This process is called rounding, right? Approximation or rounding, right? So this one, lagbhag, you take 9 rupees or you take 10 rupees, right? So this is called approximation or rounding. So by the process of approximation or rounding, what do? We take the nearest integer. Yes or no? We take the nearest integer to this number, right? So likewise, 0.9 is nearest to which one? 1, right? So therefore, it's just approximated to 1, okay? So 0.999 etc. can be also written as 1, okay? So that is the only discussion point here. Other than that, the main point is to find the answer. So 0.9 can be expressed as 0.9 bar can be expressed as 1. Okay, so 1 by 1, right? So that is the important part. Now the next question. Question 5 and question 6. We have done so many questions. We have explained everything clearly. So now it is time to use your brain, use your information that you have acquired, and do question 5 and 6 as an assignment for this chapter. Okay, every chapter I'll be giving you assignment, so make sure that you do question 5 and 6 as your assignment. All right, now I'll tell you to submit it, and that time you'll have to submit it to me. Okay, now the next one, let's look at question number 7. Now write 3 numbers whose decimal expansions are non-terminating, non-recurring. So look at here, they have told us to write how many numbers? 3 numbers, right? And they told us what kind of numbers should they be? We should write numbers whose decimal expansions are non-terminating, non-recurring. Now we have done this so many times, we have repeated that. Non-terminating, non-recurring type of decimal expansion is of which type of number? Of irrational number, right? Irrational numbers have non-terminating, non-recurring type of decimal expansion. So basically when they tell us to write 3 numbers whose decimal expansions are non-terminating, non-recurring, it simply means to write 3 numbers which are irrational, right? Because irrational numbers have non-terminating, non-recurring decimal expansion, right? So let's write 3 rational number. We know first irrational number that we commonly know is root 2. Then we write root 3. Then we write root 5. Why? Because all these are irrational. Now I already taught you how to write irrational numbers, right? You take the root and you put an imperfect square inside. You put a number which is not a square of any other number inside the root, and you get automatically you get a irrational number, right? So root 2, root 3, root 5, as you can see, 2 is not a square of any number. 3 is not a square of any number. 5 is not a square of any number. Now I cannot write root 16. Why? Because 16 is a square of 4, right? So it will become 4 at the end. So I cannot write root 16 or root 25 or root 36 I cannot write, or root 4 I cannot write because 4 is the square of 2, right? But I can write root 2, root 3, root 5, root 7, root 11, etc., right? So that is what we did here. We wrote 3 numbers whose decimal expansions are non-terminating, non-recurring. Now how do I know that? Because they are irrational. Irrational numbers have non-terminating, non-recurring type of decimal expansion. Alright. Now the next part. Question number 8. Let's read the question. Find 3 different irrational numbers between the rational numbers 5 by 7 and 9 by 11. So we have to find 3 different irrational numbers between rational numbers this and this. Now look here, we have been given 2 rational numbers. Before, what have we done? We have done this type of question, but we found what type of numbers in between 2 numbers? We found rational numbers, right? Let me emphasize it for you. We found rational numbers between 2 numbers. Yes or no? We were given 2 numbers and we found rational numbers between those 2 numbers. But here we have been given two rational numbers we have been given, and we have to find what type of numbers between them? We have to find irrational numbers between them. Okay. So how are we going to find irrational numbers? First of all, understand that irrational numbers are numbers with what? What kind of decimal expansion? Non-terminating, non-recurring, right? So anyone can make a non-terminating, non-recurring number, yes or no? So now before doing that, let's look at this number. First we need to know what this number is. What is the value of this number, right? So what is the value? Once I divide it, I get 0.714285. So you can see by the tune in which I read itself, you can know that 714285 is repeating, right? As you can see here, let me highlight it for you. You can see 714285. Then you can see again 714285. So you can see this is repeating, right? So that means this is a rational number because this is a non-terminating recurring type of decimal expansion, right? So this one again, now let me highlight this also for you. Look at this number 0.081, 081, 081, etc. So you can see clearly 081, 081, 081. These numbers are repeating, right? So this is also a non-terminating recurring type of decimal expansion. So they've already given that to us in the question. This is rational numbers. So definitely rational numbers will have non-terminating recurring type of decimal expansion, right? So we have to find 3 different irrational numbers between them. Now to make irrational numbers, anyone can make. Look, if I write 1.2, can I find an irrational number out of this number? Yes. Irrational numbers have non-terminating decimal expansion. So what kind of decimal expansion should I make? Definitely I should make one non-terminating 1.2. Let me give you an example and then we'll go into the question. 1.2. Now out of this given number, I want to make an irrational number. How do I make it? Now look here. Irrational number is what I have to make. Okay? IR, irrational. Now, to make an irrational number, I definitely know that I need decimal points at the end. Why? Sorry, not decimal points, a repetition at the end, right? I need to put points at the end. Why? Dot, dot, dot. because I know that it's non-terminating, right? So because of dot dot dot, I know non-terminating. Now what is the specialty of irrational number? The specialty is that irrational numbers have non-terminating, non-recurring. So that means 1.2. Now out of this given number, I'm going to make an irrational number. Let me write 1.2 first. Then I can put any random number I want. I'm going to put 1, 2, 3, 4, 5, 8, 9, 7, etc., etc., etc. I can put any number I want. What is the condition? Condition is it should be irrational. That means it should be non-terminating, non-recurring. So this is not terminating clearly, and it is also non-recurring. Why? Because I am just taking random numbers. No sequence is being followed here, right? So this is non-recurring also. So same way we are going to find irrational numbers between these two given numbers. Okay, so for that, let's look at the given numbers carefully. We looked at the given numbers carefully. We saw that it is 0.71 and 0.08, right? So that means we need to find numbers that exist between these two numbers. So let's look at it. Now this is approximately what? If I take this approximately, then I can take this as 0 point around. Approximation means what? To take around, right? So 0.71 is almost 0.71. So I take 0.71. I just assume this as 0.71 for my ease. Okay. Now this one, for it to be easy. Okay. Now this one, I got 0.081081, etc. So it is almost near 0.08. So I just take 0.08 for my ease, just to understand. Okay. Now that means I have to find numbers between this number and this number. Now it became easier, right? To find the boundaries. These are the boundaries. These are the boundaries under which I have to find three irrational numbers, right? So numbers between 0.71 and 0.08. So let's see. So here we have got the two numbers. What are the two numbers? The number is 0.71 and 0.08, right? So looking at these two numbers, it is clear that 0.5, does it come between 0.08 and 0.71? Yes, definitely. If you look at the number line, you know that 0 is somewhere here, then 0.08 will come somewhere here, right? 0.08 will come somewhere here. Then after a long gap, we have 0.71, right? 0.71. So this is the sequence that it goes in, right? It goes in this sequence. So we can see that 0.5 is definitely a number that lies in between this. Likewise, 0.4 is definitely a number that lies between that. I can even take 0.1 also, 0.2 also, 0.3 also. I'm just taking randomly three numbers, 0.5, 0.4 and 0.3 that lays between 0.08 and 0.71. Okay, so you can take any number that lies between 0.08 and 0.71. Okay, so now I took three numbers, but as you can see, these three numbers, all the three numbers that we have taken are terminating decimal expansion. So definitely these are all rational numbers because they have terminating decimal expansion, right? So we have to make these numbers non-terminating, non-repeating. So first thing that we have to do is what? We have to make them continuous. That means we have to put dots at the end, right? Because they are going to be non-terminating. So now it became non-terminating. All the numbers became non-terminating. Now, in order to make it non-recurring, what should we do? We should just put random numbers which is not in an order or not in a sequence, right? So let's see how did we make. Now look here. I just put random numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 5, 7, 4, 6, 8, 9, 7, 0. So can you see that none of the numbers are repeating in a sequence? It is going on and on. That means it is non-terminating, but none of it is in sequence. So it is non-recurring as well, right? So that means this is a non-terminating, non-recurring type of decimal expansion. So definitely this is an irrational number, right? So that is how we find irrational number, right? So anyone can find any irrational number. Now the next one is 0.4. It was a rational number. So I just put random numbers and I put some dots to make it non-terminating, non-recurring. Same thing I did with 0.3. So I can find as many irrational numbers as I want between these two numbers, infinite, right? So that is what we studied in the first part. There are infinite number of irrational numbers and rational numbers between any two given numbers, right? Yes, any two given numbers, there are infinite irrational and rational numbers between these two numbers. Okay, so that you have to keep in mind, right? So I found three irrational numbers between 0.71, which is 5 by 7, and 9 by 11, which is 0.08. Okay, so the next one. Now the next question is, classify the following numbers as rational and irrational. Now this is also again easy because we have been doing this for a very long time. Many times we have done this. So let's see, how do we do this? Root 23, is it rational or irrational? To look at whether it's rational or irrational, what do we do? First we look at the number, right? So inside, what is it? 23. Now 23, is it a square of any number? Let me ask that to you once. 23. Can I write 23 as a square of any number? Can I write it? Any number square? No. 23 is not any number square, right? So that means it's an imperfect square. So this is not a perfect square. This is not a perfect square. This is not a perfect square, right? So that means this is irrational number, right? When a perfect square comes inside the square root, then it is a rational number. Otherwise it is an irrational number, right? Now the next number is root 225. Now clearly 225 is 15 square, and square root and square cancels and it becomes 15. So you know how to solve this. You're in class 9, you should know, right? If you do not know, please ask the doubt, or please clarify it via video or Google or any other source that is available to you, okay? Otherwise you can always approach me, like I already mentioned in the videos or in the text as well. So you can always approach me if you don't know these kind of things, okay? So don't think that any of your doubts are small. Every doubt is important because it helps you think and it helps you grow, right? So make sure that you have cleared your doubts, okay? So please make sure that you approach someone and somehow clear it. And if you do not have anyone or anything to approach, then you always know that I'm here for you to approach, right? So I'll definitely clear your doubts. So please ask, okay? So anyway, this 225 can be written as 15 square because 225 is 15 square, right? Now square root and square cancels and it becomes 15. And definitely 15 can be written as what? 15 can be written as 15 by 1, right? So this is a P by Q form, right? So P by Q form where Q is not equal to 0. That is the condition for it being rational number. So definitely 15 is a rational number. So that is what we have seen here. We've written 15 is a rational number, okay? So the next one, let's see. Now this one, it's a decimal expansion. So let's look at the decimal expansion carefully. Here 7.478, 478, 478. You can see that this particular sequence of numbers 478 is going to repeat. 478. Next one will be again 478. So I know that it's going to be 478, 478 repetition, right? So definitely this is a non-terminating, repeating kind of decimal expansion. That belongs to which type of number? Rational number. We have done this so many times already, right? So definitely this is a rational number. Now 3 and 5, same type of question. I want you to do it as homework, okay? So in this exercise, you've got a lot of questions to do as homework. Not many, but some few questions I've given you as a homework. Why? Because only when you apply what you have learned and do the similar type of questions that we have already done, only then you'll be able to apply and you'll be able to know what to do, okay? So make sure that you do it by yourself, right? Watch the videos and do the questions and see how I have solved the questions in the videos, and according to that, please try to solve it and do it as a homework, all right? Now the next. So in the next video, we will be studying about some rules, okay? And after the rules, we will be going for rationalizing of denominators. That is another fresh topic. And then we will be closing our chapter with exponents, okay? We'll be studying some rules of exponents and we'll be closing our chapter, which means we're coming to the end of the chapter. So this chapter has been completed in 6 to 7 videos. So make sure that you have watched all the videos, you have done everything and you're up to date up until now. And in every video, I've given you some or the other work So make sure that you have watched the video so that you'll be able to know what work I have given you, and complete that work, because I'll be asking you to submit it via online or offline. And soon I will be explaining to you about your syllabus and also about the pattern of questions and everything else. Okay, so I'll be updating you regarding that once this chapter is over. So one more video and this chapter will be over. And so make sure that you have revised everything up until now and you're up to date. Okay, so in the next video we'll be doing with the rest of the chapter. Okay, up until then, study well, and thank you for watching the video. All right.